So let's talk about polymorphism. And this is a really important topic, a really interesting topic. Polymorphism allows us to make our code a bit much more cleaner by abstraction, by thinking something in a more general term. So let's get started, and it's going to be the easiest part. Just remember that the word itself, if you ever go look into what each part of it means, it's basically saying poly being a lot and morphism being basically it could change shape, let's say. Now, why is this useful for us? Well, let's look over here. I created a easy to see or read classes. The initial base class being animal, and it has a method called talk. Dog and cat both extending animal, so both dog is a animal and cat is a animal, and they're overriding talk to make it their own. Now, when I come down, let's say that we made a little program where it asks the user, do you want to create a dog or do you want to create a cat or whatever? And as the user picks them, we have to put them somewhere or keep track of them. So we could create a couple lists, right? We just saw that in the last video. We could create a list for dogs, right? And say dogs, new array list. And we could create another one for cats, pretty much. Let me just change this. So now we got two lists for cats and dogs. And as I get new cats or dogs, I would just say dogs add new dog. And if I get a cat, I would do the same thing. Cats add new cat, right? Now, because we have these two options, we had to create two different things. We had to create two different lists. And then one day happens, at some point the user says, I want to hear my cat talk. So then we create, let's say, a method. We're just making this, we're making our talk cat. We're making our life a bit harder, but this is fine. So this is our cat. And when the cat is talking, we say cat.talk, right? Pretty straightforward. So here, we're going to say, let's say the user said, make my cat talk. And we say, okay, here, cats get at position 0 or something like that. Now, at some point, the user says, I want to do the same thing for my dogs. I want to make them talk. Or if anything, we could make this into a loop and make each one of them talk or something. But to be honest, they're both saying the same thing. So our user wants also the dog to talk, but you know that all we're doing is just calling this method talk. So you think, well, maybe I could just make the talk. Sorry, I can't spell. And rather than giving it a cat, I could probably go ahead and give it a dog. Get position 0. And then you notice we got an error. Well, obviously, we're requiring a type cat, but you gave us a dog. So you go ahead and you go create another method and call it talk for dog. And over here, rather than a dog, it's, rather than a cat, it's a dog. And here it's a dog. And we're changing all the terms. But you could see that we're just repeating ourselves twice, right? And now it works. We just repeated ourselves twice, and it works. But now I got two places where I need to update or change or do things. This is where polymorphism comes in. Polymorphism, in this case, is we generalize. We think of cats and dogs as not cats and dogs, but as an animal. Think of it like a veterinarian. When you go in there, they don't really specify anything. They will check your pet, your animal, for everything that a pet would do. And then they would go in more specific terms, like what is the difference of a cat and a dog. So when your animal comes in, they would check, can it walk? Can it talk? Can it see correctly? Right? All animals can see. All animals could talk. All animals could move. And then afterwards, it could go in a specific manner. Right? So rather than specifically rather than being specific as a cat or a dog, we're going to be more as a general term. We're checking them generally. This is where polymorphism comes in. Rather than saying make the cat talk or the dog talk, we're going to just say make it talk. Actually, we could remove all of these talks and it should still work, okay? It's just gonna find the method reference. If it's a cat, it's going to call this one. If it's a dog, it's going to call this one. We could create another one and we call this one animal, right? And remember, right now, animal is our root, and we could even make it an abstract class where you can't create an animal. You have to make it a dog or a cat. It doesn't really matter. But the fact is that this is the base class. And this time, rather than getting a cat or a dog, I'm getting an animal. And why does this matter? Because I know whatever the animal is, they're always going to be able to talk. So let's try this out. Before going abstract here, it doesn't really matter. We're going to just create another one. Let's go ahead and say a talk. And rather than doing this, we're going to say a new animal. Right? The user selected animal. And now you could see that this method is being called for animal, this method is being called for cat, and this method for dogs. Right? Again, we're still having too many methods. They're all doing the same exact thing. But now, I could come out and erase these two methods, the cat one and the dog specifically one. Why? Well, because, let's erase it first. You see it's still no errors. Why can I do this? This is because a dog is an animal. A cat is an animal. And if we look, all three of them, they have talks. Actually, dog and cat inherit this talk and then they're overriding it, but they still inherited this talk. So over here, the compiler is okay with it because it knows that these two methods will have this talk. Well, what do I mean by this? We're going to go in details on how it works in memory, but what if dog had something that's specific to dog? So now, not only could it talk, but it could also bark. Bark, bark. And cat kind of has something that's specific to cat, so it could meow. Right? Really stupid methods, but the point, I hope, is going across. Meow, meow. Now, talk and meow, okay? When we call this method talk, and let's say over here I do animal dot, let's say meow as an example, you'll notice that it's not available to us. Same thing goes for barking, right? Don't get confused by the variable name. This is just the variable name. The type I'm utilizing is animal. I have access to their talks. Does it work? Well, let's try this out. Before we move forward, I just run it. And you're going to see that the talk is going to work. I am cat. That's the first initial one. I am dog, second one. And I am animal, third one. But all of them are utilizing the same method. And this is possible because, where's my pen? There we go. Because when we were creating these objects on our heap memory, right? I told you that because they're extending them, they first need to create the initial one. So when we create an animal, let's make our stack as well so you don't confuse too much. This is our heap. When we made an animal, it needed enough space to store the animal object. And it's going to reference that animal object. When we made a dog, well, it needs first to create animal for it to be able to get created. So it's going to also create an animal first. And then, this is the interesting part, and then it's going to add the part that it requires for dog. So all of this is the object of dog, but you could see that part of it is animal and part of it is dog. And that's the whole object. So why is this important? Is because when I look at a dog not as a dog but as an animal, I know that all the functionalities of an animal is inside that dog, right? It's inherent. I am confirming, I am sure that it has a method talk. It could have also been, let me erase. I hope this makes sense a bit. It could have also been that dog did not override talk. Does it matter? No. Why? Because it still inherits the method talk. It's just going to say the same thing as a normal animal. So you could see here the second one should have been I am a dog, but it still works even though it didn't overwrite talk. This is polymorphism. We are looking at the dog as an animal, as the parent. So we could generalize what it is or who it is. This one method will deal with any object that inherited that specific thing. This is because we're not going in details. We're not going to specific inherited object methods. We're not going to meow or bark, which are specific to a cat or a dog. We're talking about any general thing that's inside animal. And this allows us to do some cool things. Such as, we saw this one. Another one would be, see here I have a list of dogs and a list of cats. And this was because their types was different and I couldn't do anything about it. But what we could do is store them rather as dog or cat, we store them as animals. Now, we don't need to know which animal it is, but we will store both of them. So rather than saying dogs add new dog, we would say animals add new dog, right? So here, our reference is still to the same object that we saw before. We're still referencing, let me do an arrow here. Let me do a new color. We're still, let's say this array list that we have is still referencing to this object, but it can't see the second part. It can't see this dog part yet. The only thing it sees where the initial object is. It sees this object. It doesn't know more than the animal part. It doesn't have access more than the animal part. We could give it access to more than just the animal part, and we'll do that in a bit. But first, let's finish this polymorphism. So here, we add a dog directly to animals. So then we don't need this dog array list. We could do the same thing for cats. Rather than adding it to a cat list, we could directly add it to animals list. Oops. And now you could see that my cat and my dog has been added to the same list because they're both animals. A dog is an animal. A cat is an animal. So now I made my code a bit cleaner because I knew the only thing I was doing was holding on to those values. And rather than saying, let me just do one more. I'm going to do animals add new animal. So here you could see that I could store all three of them inside one specific array list because, polymorphism, because we're seeing those as an abstract of it, as animals. We're seeing them as a general form rather than a specific form. We're storing the parent. So here, we don't have anymore this array called cats. We have animals get 0. Animals get position 1. And over here, because we added it as well, we could just say animals get position 2. Right? And now, notice when we run it, we still get our cat and dog because they overwrote that method that was given to them by animal. Now, one problem we come out to is, well, this is great if I want to do talk, but I can't really do anything specific. So how would I get access to bark or meow? Well, even though we're getting the general form, or let's say the parents, this object still contains the cat or the dog or whatever it is. So all we got to do is ask ourselves some questions. Instance of, right? These are instances when we create the new keyword, when we specify the new keyword, we're creating an instance of a dog. So here we could say if an animal is an instance of, let's say, dog, then what would you want to do? Well, now we need to typecast it. So we're going to say dog equals this animal. Now, because this is the parent, we need to specify the cast, right? We need to explicitly cast it. So we're going to say dog, and this is fine. All right? Remember that this is the parent. It can't directly go underwards. We could have done the backwards implicitly because they all contain animal, but they don't all contain dog. Remember the loss of information. Ooh, a big thunderstorm. I don't know if you heard it. So here, if I do another animal and I just say dog, it will implicitly cast because dog is a animal. It could get into A without any problems. Here, if you miscast, let's say if it was a cat and you cast it to a dog, you'll get an exception. We could actually try that out. So we'll do it in a second. So here I got my dog, and now I could say dog dot, let's say bark, something I couldn't do with animal before. You could see that bark is not there. This would give me an error. Right? These are compile time errors. It doesn't know that this animal is a dog unless I cast it, unless I check the instance, etc., etc. So now not only would I get a talk from a dog, but I would also get a bark. And we could do the same thing with a cat. So you could see here bark, bark. Now what would happen if I don't do this check? Well, let's say I'm going to remove this check. Now you could see that the compiler doesn't know better, right? It wouldn't know until runtime what the object is coming in, if it's actually a dog or not. So now it would work fine for the first one, which is a dog, but what would happen for a cat or an animal? So look over here. I am a dog is fine. That was the first one, and we got the bark bark because this cast actually works. The second call, line 15, it's passing an animal, and it does talk. I am a cat. But the moment it tries to cast it, that animal to a cat, you're going to get this class cast exception, which basically says we cannot cast it to something it's not, right? So let's see what it says in complete terms. Class basic cats cannot be cast to class basic dog because it's two different types. So just remember that we could polymorphism. Wow, there's a huge thunderstorm. Anyway, so remember that in polymorphism, we could kind of store things as a higher level, and we could kind of grab them all together. And this gives us a lot of power. Polymorphism is utilized pretty much everywhere. Again, one of the advantages that we could see is it shortened my code. Well, this is pretty bad. Let me just bring that back. It shortened my code to one method, which takes the parent class, right? And we could store them all there because they all have this method that they share called talk. Well, share is the incorrect word. They all have a method named talk. So I get no problems. And if I ever want to do something specific, I check if it's an instance of the dog, and I could do that. The same thing, I could check if it's an instance of a cat or some other class name here. And this is really powerful. And I hope we're going to see it nonstop from now on. So I hope you get used to it, familiarize with it. This is a topic that's a bit hard to grasp. So the only thing you need is practice and a bit of thinking. See you guys in the next video.